Welcome. In this video, we introduce the crucial concept of database normal forms, which are essential for efficient database design. We begin by examining a common problem in poorly structured databases: data redundancy. Redundancy is simply the repetition of related values within a database table. This is often a sign of an unoptimized structure. For instance, consider a booking table where information like Elvira Yin and her passenger number 222 feet might be repeated across multiple rows if she has multiple bookings. While redundancy might seem harmless, it leads to several significant problems in database management. When related values are redundant, updating requires changing every single copy. If even one copy is missed, inconsistencies arise, and you can no longer trust the data. Redundancy also slows down queries and makes them unnecessarily complex, as the database must process multiple copies of the same information. To combat redundancy and its associated problems, we turn to database normalization. Normal forms are a set of rules for designing tables to systematically reduce or eliminate data redundancy. Normal forms are sequenced from first through fifth, with Boyce-Codd normal form, or BCNF, offering a stricter version of third normal form. Each subsequent form allows less redundancy than the last. Understanding the root cause of redundancy helps us appreciate the solution offered by normal forms, especially BCNF. Redundancy often occurs when one column depends on another column that is not unique, leading to repeated data every time the dependent value appears. Boyce-Codd normal form, or BCNF, tackles this directly by requiring that all dependencies in a table must be on a unique column. Due to its effectiveness in eliminating most data anomalies, BCNF is generally considered the most important normal form in practical database design. Beyond BCNF, there are further normal forms that deal with increasingly complex and rare dependency issues. Fourth and fifth normal forms eliminate multi-valued and joined dependencies, which are rare occurrences in typical business data. Because these forms address such uncommon scenarios, fourth and fifth normal forms are primarily of theoretical interest to most database professionals. Now, let's set the focus for the remainder of this learning section. This section will primarily focus on the practical application of the first, second, and third normal forms. BCNF is covered in a separate, more advanced module, and the fourth and fifth normal forms are generally not included in this core curriculum.
So let's look at figure 3.10. So we see that at the very high end, the first normal form has the greatest redundancy, while the fifth normal form has no redundancy. So as you go down like a stair form, when you're coming from the first, second, third, Boyce-Codd normal form, fourth normal form to fifth normal form, redundancy tend to go down. So redundancy, now let's do this participation activity so that we may get to do this exercise. So redundancy, the first question says redundancy is the repetition of an individual value. So let's see if you said false. So if you said false, you are correct, because redundancy is the repetition of related values such as 2222 Elvira Yin. So if you're looking at this table, redundancy is the repetition of these values. First class, boarding zone number 1. Okay? So that defines redundancy. Then let's go to question 2. Tables that allow redundancy might contain inconsistent data. So let's say you said false, okay? You are wrong, because redundant tables have multiple copies of the same data. Inconsistency results when updates are not applied uniformly to all copies. Okay, now let's go to the first question and say redundancy is the repetition of an individual value. So what if you chose true? You see that redundancy is a repetition of related values, right? So if you chose false, then you're correct. Then for this, redundant tables have multiple copies of the same data. So inconsistency results when updates are not applied uniformly to all copies, right? Okay, dependence on a primary key can cause redundancy. What if you chose true? So redundancy occurs when the column depends on another column that is not unique. So dependency on a unique column never causes redundancy. So since a primary key is necessarily unique, dependency on a primary key cannot cause redundancy. So this is false. So redundancy occurs when a column depends on another column that is not unique. Dependency on a unique column may cause redundancy. So since primary key is necessarily unique, dependency on a primary key cannot cause redundancy. So let's match the normal form to a description. Okay. So we've seen that as you go down, when you're looking at normal forms, the greatest redundancy is with the first normal form, and the lowest redundancy is with the fifth. No redundancy is the fifth normal form. So if you're looking at this table, this practice, so you are told that fifth normal form eliminates joint dependency and associated redundancy, allows most, that is not correct, eliminates all redundancy arising from dependencies on non-unique columns, eliminates multi-value dependency and associated dependency, the redundancy. Okay, so first of all, we disallow this. This is not true. Arising. So for this, so let's start with the eliminates or redundancy arising from dependencies on non-unique columns. This should be the Boy's code, and that is correct because the Boy's code normal form, redundancy occurs when a column depends on a unique column, that we all agree. So the Boy's code normal form eliminates all such functional dependencies and therefore all associated redundancy. Now, let's come to this eliminates joint dependency and associated redundancy. Okay, let's do fifth, because the fifth normal form informally a joint dependency occurs when a table is in the join of other tables with fewer columns. So to achieve fifth normal form, the larger table must be replaced by the smaller table. So joint dependencies are the most general type of dependency and include functional and multivariate dependency. However, joint dependencies that are not functional dependencies are uncommon. All right. Okay, now let's do part one, eliminates multi-value dependencies and associated redundancy. So this must be the fourth normal form, because informally a multi-value dependency occurs when two independent plural attributes are implemented in the same table to achieve fourth normal form. Independent plural attributes must be implemented in separate table. And finally, first normal form allows most redundancy of any form. So first normal form is the least restrictive normal form and allows most types of dependency. Now let's get to first normal form. Let's look at each of these normal forms in the next video.
To conclude, let's recap the benefits of normalization. Normal forms provide a systematic methodology for designing robust databases, ensuring high efficiency, consistency, and reliability across your data.